All right, we're recording Monday morning geometry first period lesson, chapter 9 review, starting on page 395G in Braille and 395 at the bottom of 395 in print. And what's this section dealing with? What does it say? 9-5, use proportions to determine whether lines are parallel to sides of triangles. So one of our sections we had parallel lines where a parallel line would go through a triangle and it creates another similar triangle to the big outside triangle. So now we do the converse, and if we prove proportionality, then we can say that yes, that line is parallel to that side opposite. So that's what it's saying in here, is that you determine whether line LM is parallel to line JK in the figure. And so you have a figure, a triangle where J is the top vertex and N is the very bottom left. So you have a big outside triangle, J, N in the bottom left, and then K is the very bottom right. And so that's the outside of your triangle when you bring all those points together. And then going through the midst of the triangle from the 10 o'clock to 4 o'clock position. So parallel, or we're going to prove it's parallel to JK, is L. No, yeah, you are. Turn one more page. There you go. Is from point L to point M. And we're supposed to prove that LM is parallel to JK. So J to L on the top left side, that segment is 2. And from L to N, that segment is 6. And then on the bottom side, from K to M is 3. And from M to N is 9.
So those would be...
Yeah, go ahead, Bryant.
Because if you simplify them, they're both 1 to 3.
Excellent, yes.
So
2 to 6 is the same as 3 to 9. So those are proportional. Yeah, excellent. Paying attention there. So because those are proportional, we're able to say that line LM is parallel to JK. So you can do proportionality based upon each segment. We learned that we could do that. We could also do proportionality based on small triangle to big triangle. We could have done 6 to 8 for JN. We could have added the 6 and 2 together and got 8. So our big side of our triangle is 8, and then 6. 6 to 8 is the same as 9 to 12. You could also prove it that way, as long as you just make sure they're proportional.
So this one we do.
You could do 2 to 6 and 3 to 9. Are those the same?
Mm-hmm.
Yeah. And Bryant just reduced them. He said they're both 1 to 3. If you take 2 to 6, it simplifies to 1 over 3.
So they are
and 3 to 9 is 1 over 3. So yes, they're proportional. So therefore, you're able to say yes, LM is parallel to JK. Hmm? Now they did it where they said let's do one side of the little triangle 6 to 8. Or no, they actually did 2 to 8. Interesting. So you could even do that too. You could go 2 to the whole side 8 is the same as 3 to the whole side 12. There's several ways we could go about proving proportionality. So just make sure you do it, and then you determine that they're parallel. And if they weren't proportional, you have to say no, they're not parallel. So we take a look at the next drawing on the next page, H 395. You've got an inverted triangle. A is the top left, B is the top right, and then E is the very bottom. So there's the outside of your big triangle. And then there's a line running through the midst of it east to west through points D and C. And they're saying the entire side AC, there's a bracket, and pointing out to it saying that that is 13. And then from A to C is 5. So you could go, okay, well, I could do C to E is what? The whole thing is 13, and A to C is 5. What is C to E? 8, right? Okay. And then on the right-hand side, they have B to D is 4, and D to E is 8. So is CD parallel to AB? Yes or no? So what proportionality would you like to check? 5 is to 8, right? As 4 is to 8? Is that the same thing? No. No. Understand, Abby? You check the proportionality.
We do 4 over 8 and 5 over
8. Do those equal each other? No.
5.
No. Not even close, right? Or we could do 5 is to 13 as 4 is to 12. We could keep the big side and add the other two together and get a big side, and still it's not correct. 5 is to 13 is not the same as 4 is to 12, is it? We could go backwards. 8 is to 5 as 8 is to 4. Nope. Right? So there's several ways you can go about proving that they're not proportional. So therefore, CD is not parallel to AB. All right? Turn the page. This is a classic end of course type exam question where they're going to have a triangle and they're going to have several lines going through the midst of it that create another small triangle inscribed inside your triangle that actually creates many triangles. So very carefully we'll read through this. First in the givens it says A, B, and C are the midpoints of the sides of triangle STU. So your brain should kick in. You're on the right page. Turn back, Abby. You're on the right page.
Oh, I turned the 2 of them.
No, one more. All right, so A, B, and C are midpoints. So your brain should kick in and you go, oh yeah, midpoints. Okay, there's some really cool stuff about midpoints. I know that they bisect the sides. I know that then they're parallel to the sides opposite. And I also know that the segment they create from midpoint to midpoint is half of the side opposite it. Remember that? That's one you want to put to memory. So midpoints are really cool in a triangle because they create several different things going on. Parallel lines, bisection, and half the distance of the side opposite. So we have a top vertex of S, a bottom left vertex of U, a bottom right vertex of T. That's the big outline of your outside triangle, STU. And then on each side is a midpoint that when you connect it to the side opposite, you create this parallel line. So A is on the left, running west to east to point B on the right. And both of those points are midpoints. So we know SA and AU, they're congruent. They're the exact same distance. SB to BT, congruent, because we were told, we were given A and B are midpoints. Then from A, if you go at a diagonal from about 10 o'clock to 4 o'clock down to the bottom of your triangle, you get to point C. And you're told C is also a midpoint. So you know from U to C and C to T. Those are the same because that base has been divided in half. And then we go back up to B, and from C to B, it's another parallel line to our side opposite, U to S, and you know that T to B is the same as B to S. All right, so several things going on here. 25 asks, right below the triangle, AC is parallel to question mark, blank, question mark. So AC is parallel to what?
No.
Find AC,
Oh,
and then the
yes,
side
it is.
opposite. ST, good, excellent. And you say it in that order. If you started with A on the left, C, then you go start with S on the left, T. Good. If UT is 16, then what is AB?
Okay. 32.
No,
Okay, 8.
8, right.
Oh,
AB
this
is
one
half the distance of UT because of the midpoints and it's parallel. All right, if BC is 6, then SU is what?
Oh, that one is double.
12, right? Yeah, that would double me 12. Excellent.
I keep getting forget when we start.
Also use your common sense when you're feeling that line on the triangle and it's, 16 and it's really long, and then you go to look at a shorter one, it's not going to be 32, is it? It's not going to be more than it, right?
So,
okay.
What is the last question again? What last question?
It said BC is 6. What is SU?
Oh, so midpoint 6 and the whole thing, like at the other side, is
Double.
double.
Always. If they're midpoints. If they're anything else, it's not. But if you're given that they're midpoints, it will always be a 1 to 2 ratio. Okay? All right. Turn the page, or actually, that's a page break. 396. So this is section 9-6, and it had to do with identifying and using the relationships between parallel lines and proportional parts. Okay, so we'll turn the page, take a look at those. Oh, they're waiting for our call. Hold on. Stormy's here. We'll give it a minute here.
Did you pause the recording?
What's that?
Did you pause the recording?
Did I what?
Pause the recording.
Pause? No, I didn't. I'm just recording while we wait. Da-da-da-da-da. We can hum along. You can take a look at your drawing while we're waiting. There's Stormy. Come on, me and Stormy. There she is. Hi, Stormy Sue.
Hi. I don't know what that was.
We were trying to call you a little bit ago, and we tried a few times, and it didn't happen, and we thought maybe you got...
we didn't get anything until just right now. Yeah.
You had hispy punishment or something.
No, I don't know what that was.
Hispy detention.
No, I didn't make it.
So,
No,
Stormy, I started recording the lesson just in case, and I'll continue to record it. So we're recording right now, and then I'll just send all of you the recording so you can catch up on the beginning of it. And Brian also asked to have it recorded. He's with us, but he's not going to get his textbook till later.
Okay.
All right? We are on page 396A, and it's in volume 36. 396A.
Okay, here we go. I don't know. 396A.
And there's a graphic of 3 parallel lines with 2 transversals.
Way back here.
Yeah, it is. Yep.
When I miss that to what?
A.
And what are you in print?
396 at the very top.
Is that no. Okay, I found it.
All right, awesome. So there is a graphic of 3 parallel lines. It's reviewing the concepts about this section in parallel lines and proportionality with transversals. And so there's 3 parallel lines and then 2 transversals. One's on the left from about 11 o'clock to 5 o'clock, and one's on the right from about 1 o'clock to 7 o'clock.
Okay.
Got it?
Yeah.
All right. And then I'm trying to, it takes a lot to draw these in. A lot of lines to color and arrowheads. And then it shows on the transversal, it's giving some measurements of the segments. On the left-hand side, from the top intersection point of A to the mid-intersection point of B, and then there's a lower on the third line an intersection point C. And we're reminded in symbols that BC is to AC, so we could take one piece of our transversal and make it a ratio to the larger piece of our transversal. And then we go over to the right-hand side and we have 3 points D, E, and F where that transversal intersects the parallel lines. And it's saying that if BC is to AC, then EF would be to DF. Yes, Abby. Excellent. Yeah.
Yeah.
So it's just reminding you that when you have 3 parallel lines and you get a transversal going through it, any 2 transversals, they will be proportionate to each other, because what they're doing is if you were to extend those transversals, they would eventually intersect and they would create triangles. And so it's using triangle principles of proportionality, similar triangle principles, and also all of our parallel line information. If we were given the measure of an angle, we would be able to figure out the measure of all the other angles and start proving that with proportionality. So let's complete the proportion for 28 right at the very bottom of the page. It says complete the proportion. AB is to AC as blank is to DF. So using the same drawing, AB is to AC
396.
as blank is to DF.
D-E.
Oh, DE.
There you go.
Did you say, what was that, DE?
Yeah.
Excellent, good. So yeah, the top segment is proportionate to the entire thing, as the other top segment isn't proportionate to the entire. All right?
Yeah.
Let's turn the page, and there's another drawing to look at. So we have it says find the value if x is parallel to y is parallel to z. So they're giving us that x, y, and z are parallel to each other. The parallel lines are running up and down, running vertically, north to south. So x is the first line, and then it goes in alphabetical order, y and z. Okay, so they're parallel lines. So sometimes, parallel lines, they can be in any position. They don't always have to be east to west. And then there's two transversals running sort of horizontally. They're slightly skewed. And the top one intersects the three parallel lines in three places. The top one intersects at P, G, and R. And the bottom transversal intersects at 3 points. And they labeled those just below the parallel line, it looks like. The bottom one is at S, T, and U. And then they give some measurements of the segments. So in the top transversal from P to G is 12. From G to R is 16. From S to T is D, little letter D. And from T to U is 20. And we have to figure out the value of D. How would you like to do that? 12 over 16. Okay. 12 is to 16 as what? No. D over 20. Yeah, be very, very careful that you're positioning, because on a multiple choice test, one of the answers will be for 20 over D. They're trying to catch the student that does not pay attention and put it in order. Okay? So if you go little segment to big segment, you have to go little segment to big segment on the next one. All right?
Mm-hmm.
Wanted to choose 16 is to 20 as, or 16 is to 12 as 20 is to D. That's fine. Okay. All right. So then you have 12 is to 16 as D is to 20. How are we going to solve this?
Multiply.
Multiply. Yes. 12.
Multiply.
Yeah. Cross multiply, cross products. Right. So 12 times 20. No calculator. What's 12 times 2? 24. And add a 0 on the end. 240. All right. Equals 16D. Okay.
Then we can use our calculator.
Then divide 240 by 16.
Fair enough.
Oh my lord.
15.
15, yes, 15. Alright, so D equals 15, good. Okay, turn the page. Last section of chapter 9. This is lesson 9-7. And then this one, we identified and used proportional relationships of similar triangles. So we put it all together and used all our knowledge from the entire chapter to find missing sides, using perimeter. Remember, we learned in this section we could use perimeter even, because if the sides are proportional, to add them together is also, their perimeters will also be proportional. We used this to figure out scale factor by reducing. So you have two triangles. You have a small triangle on the left and a similar larger triangle on the right. And we're going to determine the scale factor of triangle ABC to triangle XYZ. So your little triangle on the left has A in the top left, a very messed up brailing of B on the top right.
How was that supposed to be?
I know, and it looks
like almost like a C.
It's weird. What did they try to do there? It's like they double brailled it over the top of each other. It looks like
Yeah, they can.
weird. All right, and then C in the bottom left. Kind of appalling that they got credit for transcribing this. All right, A to B is 4. on the very top, A to C is 3, and B to C is 5. All right? And then we have a big triangle next to it. X is the top left, Y is the top right, and then Z is the bottom left. So it looks like these are in similar kind of positions. They're just a slide, aren't they? Slide to the right and down. All right, from X to Z is 6. From X to Y is 8. And from Z to Y is 10. So what is the scale factor? From A, B, C. You could find the perimeters if you want to, or you can just do corresponding sides to find a scale factor. So,
like 3 to 6.
what did you say, Abby? 1 to 2. Yeah. So you just take a corresponding side, like AB corresponds with what?
XY.
Good job, Stormy. XY. So take those two measurements. 4 is to 8. And just simplify it, right? And 4 is to 8 simplifies to 1 is to 2, correct? If you check all of them just in case, because you want to be thorough, 3 is to 6, 1 to 2, right? 5 is to 10, 1 to 2. And be very careful how they asked you. They said the scale factor of triangle ABC to triangle XYZ. So where they're going from little to big. If the question would have been triangle XYZ to triangle ABC, then what is your scale factor? 2 to 1, exactly. And what does this mean? This means that ABC is 1/2 the size of XYZ, isn't it?
Yeah.
Or XYZ is double ABC. That's what scale factor means. All right, let's go test it out on the next problem. Turn the page, 396B. All right, what do we have here? We need to complete the, oh no, sorry. The triangles below are similar, and the perimeter of triangle NPQ is 27. Find the value of each variable. So we got to do a little bit of work on these problems, don't we? First, we want to really make out what we're looking at. So we have a big triangle on the left. K is the top left vertex. L is the bottom left vertex. And M is the bottom right vertex. They're showing 2 congruency arcs at vertex L and 1 congruency mark at vertex M. So what similarity test are they using most likely? Angle, angle. Good. Good. Angle, angle. Excellent. From K to L on the left-hand side is 8. From L to M on the bottom is 12. And the side opposite vertex L, KM is 16. Okay. Now we go up kind of top right, kind of a slide where it went over right and up to our similar triangle. N is the top left, P is the bottom left, and Q is the bottom right. And at vertex P are 2 tick arcs, and at vertex Q, 1 tick arc. So, yep, there we are. We've got angle, angle, don't we? From N to P on the left-hand side is X. From P to Q on the bottom is Z. And from N to Q is Y. All right. And you are given that the perimeter of triangle NPQ is 27. Perimeter equals 27. Okay. So what's our first step that we need to do before we can even move forward? We want to add up the big one. We want to find the perimeter. Excellent, Abby. Right. All right, so 8, 12, and 16. What's the perimeter of our big one?
36.
Good. Okay. So we have a ratio of 27 to 36, don't we?
Mm-hmm.
All right, so we have this 27 to 36. Now, if you wanted to make your life easier, you could simplify that. 3 to 4. Yep. Okay. So you can use a 3 to 4 ratio to figure out the rest of these. All right, and that makes the math easier instead of cross multiplying 27 times something and 36 times something and dividing by some big number. Take it down to 3 to 4 if you can by dividing both the top and bottom by 9, right?
Yep.
Okay, and that's your scale factor, isn't it?
Yep.
Yeah. All right, so if we do 3 is to 4, then x is to what?
X is 2.
3 is to 4 as x is to 8, all right?
Yeah.
So cross multiply. 3 is to 4 as x is to 8. 3 times 8, 24, good. Divided by 4, 6. Excellent. All right, so x is 6. All right. 3 is to 4 as y is to 16.
The answer is 12.
Yeah.
12, did you say, Jet?
Yeah.
Yep. 3 times 16 is 48. Divided by 4 is 12. All right. 3 is to 4 as z is to 12. What did we say first? 3 is to 4 as z is to 12. What do we say last? 12, right? You always, first and last, you are your extremes. You multiply those. So 36 divided by 4, 9. Yeah, 9. Okay? So couple of steps you have to do on these. First, you got to make out your drawing. You got to recognize the perimeter. Then you realize, oh, I need to find the perimeter of my other one. So we got to do a little basic addition. Then make your life easier. Think smarter, not harder. Take your ratio, 27 is to 36, and reduce it 3 to 4, and then start going, right?
Mm-hmm.
And remember, we went from small to big, so keep going small to big on your corresponding sides. If you would have chosen 36 to 27, that's fine, but then you would say 4 to 3, correct?
Yeah.
Go large to small. Be very careful on how you set it up and keeping it set up that way each time, all right? All right, turn the page. We just have to do something pretty simple on this one. It just says at the very top, 31. Determine the scale factor of triangle DEF to triangle ABC. So that's just where you got to be careful. So DEF is on the left. D is the very top. E is the bottom left vertex, and F is the bottom right. There are congruency marks, which is interesting. This taps into our knowledge. We don't really need it for this problem, but it's good to practice it. E has 2 congruency arcs, and F has 2 congruency arcs, and D has 1. What kind of triangle is this?
Scaling.
Not scalene.
No.
Not equilateral.
Isosceles.
Isosceles. Yeah, isosceles have 2 congruent angles and 2 congruent sides. What are the congruent sides called? Legs.
Legs.
Yeah, legs. Excellent. All right, so when you make out the drawing, of course, on the left-hand side, DE is 16, and on the right-hand side, DF is 16. And then at the bottom, EF is 12. Then we go all the way over to the left-hand side. For some reason, they wanted to put the triangle way over there. We have A at the top, B at the bottom left, and C at the bottom right. Got congruency arcs again. So what similarity test are they using to prove, to state similarity on these two triangles? Angle. Yeah, we just need two, don't we? It's
Yeah.
angle. But also a scalene, two congruency tick arcs at B, two congruency tick arcs at C. A to B on the left is 21. No, 20.
It's just right.
Yeah, it ran right into your side. And then A to C is 20. And then B to C is 15. So what is your scale factor?
$16 to $20.
16 to 20, all right. Now, you got to take it one step further. Mathematically, yes, that's your scale factor, but it's not pretty. What can you do with 16 over 20?
Reduce it.
Reduce it, excellent. What does 16 over 20 reduce to? 4 to 5, good. 4 to 5. So the little triangle is 4/5 of the big triangle. Just slightly smaller, isn't it?
Mm-hmm.
Or if we flipped it and went ABC to DEF, we would say what?
5/4.
5 to 4. So that means 5 to 4. So that means the big triangle is 1 1/4 bigger than the little DEF. It's a fourth bigger, isn't it?
Yeah.
All right. Good job. Okay, we got a problem down here on page 32. It doesn't require a drawing, so it's underneath your triangles. It's applications and problem solving. 32. Big paragraph of information. You find that? So it says the sail on John's boat is shaped like a right triangle. So we stop there and think like geometry students and think about a right triangle. I'm going to have a 90-degree angle. I'm going to have two legs and a hypotenuse, right?
Yep.
Okay. And I'm going to sneeze. All right.
Bless you.
Its hypotenuse is 24 feet long. One leg is 16 feet long and the other is about 18 feet long. So visualize you've got a right triangle with a 16, 18, and 24, right?
Yep.
The triangle sail on the model of the boat has a hypotenuse of 3 feet. If the two triangular sails are similar, how long are the legs of the model's sail? So the hypotenuse on the little model is 3 feet. So what is your ratio that you're going to use?
The other one is
24, right. And you have 16 and 18, right?
Mm-hmm.
So how are you going to set this up?
Oh, can we use the way?
You could use perimeter, but that's kind of overkill. They give you a ratio, don't they? They give you hypotenuse to hypotenuse. What is that?
3.
24 to 3 or 3 to 24, right? And you could reduce that. That's 8 to 1. 8 to 1. All right. So then your other leg is 16, right?
Yeah.
So 24 is to 3 as 16 is to x.
So that's what you would do.
Or 8 is to 1 as 16 is to x. 24x equals 48.
Divide by 24.
Divide by 24, and x equals
2.
2.
Good. Excellent. Or you could have 16 is to x, and you'd have 8x equals 16. 16 divided by 8 is 2, right? So it's an 8 to 1, right? All right, so we do 8 to 1 again. and our other side was 18. So 8 to 1 as 18 is to x. So you get 8x equals 18. X equals, how many times does 8 go into 18?
2.
2, remainder
2.
2. So 2
Yeah.
and 2 eighths. And 2 eighths reduces
1/4.
1/4. Good. 2 1/4. Yep. All right.
Yeah.
So one of the sides would be 2 1/4. One of the sides would be 2. Okay. So we didn't need a drawing for that. All you needed to do is think about, oh, I've got a right triangle. I've got these 2 legs and a hypotenuse. They gave me the hypotenuse of both. I can figure out that ratio. It's 24 to 3. You can make your life a little easier by reducing it 8 to 1. Then you're not multiplying 24 times anything, right?
Yeah.
And then you solve for each side using cross multiplication and division all day long. All right, let's take a look and see if the next problem is readable. It's not too bad. They say this is a swing set. So up at the top, let's read the problem. It says the ends of the swing set at Parkdale Elementary School look like the letter A.
Oh, letter it look like.
Yeah, the print letter A. So, and as shown in the diagram, if the horizontal bar is parallel to the ground, how long is the horizontal bar? All right. So we have a left-hand side of our swing set. We have a right-hand side of our swing set, and then there's a little swing in the midst. Don't even ignore that. That's eye candy. All right, and then there's a bar going through the midst of it, and they're saying that bar is parallel to the ground. On each side of the swing set, on the left side from the top vertex to that bar, it's saying that is 9 feet. And from the bar to the ground, they're saying that's 9 feet. Aha! On the right-hand side, it's the same thing, 9 feet and 9 feet. So that bar is doing what to those sides? Where is it intersecting at? What's important about 9 feet, 9 feet, 9 feet, 9 feet? It's dividing by what?
Yeah.
They're congruent because that bar is doing what? It's intersecting those sides at what? At what special points? Come on, geometrists.
Monday.
You get 2 equal parts. Where is that bar? What is it called when it does that? When it intersects those sides? Midpoints. Midpoints. Come on, come on, come on, come on. Don't flush this. It doesn't. You just have to think. This is a swing set. You just got to be putting your geometry brain on. You got to go, oh, 9 feet, 9 feet, 9 feet, 9 feet. I know that bar is intersecting those sides at midpoints. What do we know then about parallel lines that intersect at midpoints if we want to figure out their measurement? We go all the way down to the bottom and it says from pole to pole is 7 feet. So what they're asking you, how long is the horizontal bar? Down at the bottom, from pole to pole is 7 feet. How long is the little horizontal bar in the middle?
7?
No,
So we reduce that.
you don't reduce anything.
Don't.
You pull up from your memory what you're hopefully starting to think about and memorize. What is the relationship between a parallel line of a triangle intersecting at midpoints to the side opposite it? We just did this in a section 2 sections ago. What is its relation? They're not congruent.
Well, like, we did what I can't remember is
The bar is 3.5 and y'all crashed the space shuttle.
I say 3.
It's 3.5. Why is it's 3.5? Why is it 3.5?
Money.
You divide what?
Like a 7.
7 by 2. Yes.
I don't know. I know. I just guess.
So you need to refresh your brain with section 9-5. A line that goes through a triangle that is parallel to the side opposite and intersects the other two sides at midpoints is always half the length of the side opposite. So by noticing that the swing set was 9 and 9 and 9 and 9 on each side, you then knew that that bar intersected those sides at midpoints. So you go, aha, then I know that bar is half the size of the side opposite. And the side opposite is from post to post, they're saying down at the bottom is 7 feet. Half of 7 feet is 3.5 feet. Okay?
Mm-hmm.
Got to put that to memory. All this stuff's got to be put to memory. Don't flush it. You can't just in the moment be doing basic math and then move on and don't remember why you did it. All right?
Mm-hmm.
All right. That is all of chapter 9. You have been reviewed. You shall take an exam tomorrow. All right? I am going to stop the recording right now and we did lose Bryant. He just texted me, so I think I lost you.